to the shell of the oxygen sensor, you can just hold it like this.
Okay.
Now I'll insert it in the flame, and we'll see if this oxygen sensor can produce 9/10 of a volt within 1 minute.
Okay. Well, it's already starting to produce a voltage. 5, 6, 7, 8, 9/10 of a volt already.
Okay, so far so good.
Yep.
Now I'm going to pull it out of the flame, and we'll see if it drops.
1001, 1002, 1003. And it's right back down to 0.008 and dropping.
Okay, great. So I think that this one here, although it still functions, has just been in there quite a long time and was replaced just because of maintenance. So this is a good oxygen sensor, and that's how you can tell if they're good or bad right on the bench.
Okay.
Now one thing I'll do though is put this down into an ashtray or someplace where it can cool off, because they're quite hot for a while.
All right. Now there's an on-the-vehicle test that can be performed also. And why don't we head out in the garage and show them that one?
Okay.
Now, along with the simple bench test, you can also test your O2 sensor right on the vehicle, and we're going to demonstrate that right now, right, Jim?
That's right. Now, basically what we're going to need, Scott, is a voltmeter set on the 2-volt scale because the O2 sensor produces a very small voltage. And I'm going to connect the voltmeter first to a good ground. The negative lead gets connected to a good engine ground.
Sure.
And then I'm going to reach over and unplug the O2 sensor lead and connect the positive lead of the voltmeter to the O2 sensor's lead. Now we'll be able to measure the voltage while it's right in the engine. Now we're going to have to run the vehicle and change the air-fuel mixture ratio. A simple way to do that would just be to create a vacuum leak.
Sure.
And there's a vacuum port right here on the top of this engine with a little rubber cap on it. So if you have one of these on your car, there's a little clip that you can use a pair of pliers to remove and get that out of the way, and then simply pull the little boot off. And that will create the vacuum leak that you need to change the mixture. So I'll start the car, and we'll do that.
All right. Now, we've previously run this engine for a little bit of time to warm it up, too. Okay. We might need to run the engine for a little additional time, and our meter's starting to come up now. So I think our O2 sensor is warm enough. And it does have to be at least 600 degrees Fahrenheit for this test to work.
Now I'm going to go ahead and open up the vacuum port, and we should watch the numbers drop as we lean the mixture.
Yep, going way down. Put your finger over it, plug the vacuum leak, numbers go back up. Way down, and back up.
Now, as you can see, the engine almost stalled on this test, and on some vehicles it actually would stall. So on those vehicles, we'll have to do something called a propane enrichment test.
Sure.
And so I'm going to take this valve, which we have screwed to a propane bottle. It's a regular propane bottle with a special valve on it for doing this test, and connect it to the vacuum port.
Okay, now we have a slight vacuum leak introduced. So we're seeing a real low voltage on the voltmeter, which is a signal of a lean mixture. Now if we open the propane bottle up, our reading should go up. There it goes, way up.
And as I shut it off, it goes back down.
Way back down.
But this gives us the opportunity then to test an O2 sensor on the vehicle with either a vacuum leak or a propane enrichment test.
Let's review the test procedure for an oxygen sensor that has been removed from the vehicle. The first step is to visually inspect the oxygen sensor. Normal coloration will be light tan. White, black, red, or light gray deposits are sign of a contaminated sensor. Connect the red lead of the digital voltmeter to the black lead from the sensor. Connect the black lead from the digital voltmeter to the body of the sensor. Set the meter to the 2-volt scale. Heat the sensor tip in the flame of a propane torch. The voltage should exceed 0.9 volts within 1 minute. Remove the sensor tip from the flame. The reading on the voltmeter should reach 0.1 volt or less within 3 seconds. If not, replace the sensor. Now let's review the testing procedure for an oxygen sensor that is still installed in the vehicle. Connect the red lead of the voltmeter to a pin that is back probed into the oxygen sensor connector. connect the black lead to a good engine ground. Locate a good manifold vacuum source. Start the engine and run it until the meter reading begins to toggle over and under 0.5 volts. Create a vacuum leak at the port or source located earlier. Observe the meter reading. The voltage should drop below 0.1 volt briefly with the vacuum leak and should rise above 0.5 volts when the vacuum leak is plugged.
Your vehicle's oxygen sensor is located in the exhaust manifold or pipe ahead of the catalytic converter. An oxygen sensor resembles a spark plug and has 1, 2, or 3 wires attached to it. For peak engine performance, we recommend replacing your oxygen sensor every 25 to 30,000 miles or every 2 years. The items you will need to replace your oxygen sensor include a socket set and torque wrench, an oxygen sensor socket, some penetrating oil, a wire cutter and crimper, some anti-seize compound, a cigarette lighter, a soldering gun and solder, and the correct replacement oxygen sensor for your vehicle. The first step in replacing your oxygen sensor is to start with a cool engine. In most instances, the oxygen sensor will be readily accessible. However, we remove the air cleaner for better viewing of the procedure. Then locate the sensor and spray some penetrating oil on the fitting to help loosen corrosion. Oxygen sensors are available with original equipment leads or as a universal type. Our demonstration will detail the steps involved for the installation on a universal type. Cut the existing wire or wires as near the sensor as possible. Disconnect the sensor connection on the other end of the wire and place the wire on the workbench. With a socket of the correct size, remove the old sensor from the exhaust manifold. For ease of removal, you may want to use a special oxygen sensor removal socket as shown. Some replacement sensors may come with fewer leads than the one you removed. For installation of these type, please refer to the instructions included with it. Slide a piece of heat shrink tubing over the new oxygen sensor wire and strip about 1/4 inch of insulation from the ends of the wires that are to be connected together. Reconnect the old wire to the new sensor with a crimper and butt-type wire connector supplied. We suggest soldering this connection with rosin core solder for a positive corrosion-free connection. For wiring details on your particular vehicle, consult the complete wiring instructions included with your new oxygen sensor. Then slide the heat shrink tubing over the connection and collapse the tubing with the heat gun or lighter until it shrinks and weather seals the connection. Most oxygen sensors come with anti-seize compound on the threads, but if yours doesn't, place a small dab of non-volatile anti-seize compound on the threads prior to installation. Do not, however, allow the anti-seize compound to get on the bulb of the sensor. Install the new sensor in the threads, starting it by hand, and tighten it with a torque wrench to 30 foot-pounds. Reconnect the sensor wire at the factory connector, and make sure the wire is routed away from any moving parts and the exhaust manifold. Reinstall the air cleaner assembly if earlier removed, and start the engine to ensure proper installation of the sensor. For a written version of testing and replacing your oxygen sensor, pick up your free copy of Champion Auto Store's Tech Tip number 37.
Now let's review the steps involved in replacing an oxygen sensor. As always, begin with a cool engine. Cut the old wire from the oxygen sensor near the sensor itself. Disconnect and remove the old sensor wire at the snap lock connector. Remove the old sensor from the exhaust manifold or pipe. Strip 1/4 inch of insulation from the electrical wire attached to the sensor and